Okay. Okay. Good afternoon, everybody. Welcome to the second live session of the advanced course of Aspen Plus. So I find quite a few people over here. So we have Vania Aryan. I'm surprised to see Vania Aryan here. I do not know how come. So Vania Aryan, are you registered with both the courses, basic and advanced? Actually, it is not. I mean, I do not know how you are managing these two, because until unless you are thorough with the basic course, your advanced course will not be correct. You know, I mean, advanced course from the very first week we are supposed to teach from the advanced level, because you are supposed to know the entire course of basic. So even if you are, even if you do qualify for the course, I do not think you will be able to, learn anything. Well, that's not the question, Vanian. I mean, it is about learning and then answering, because in the beginning of the basic course, we teach how to use the software. And in the advanced course, from the very first week only, we assume that the corresponding student knows how to use the software. So I'm not sure how in the very first week of the advanced course, how you could answer or perform the simulation without knowing the basics of Aspen Plus. So that was my question. So we always encourage people to do it sequentially. In one semester, you do the Aspen Plus Basic, and the next semester, you do Aspen Plus Advanced. Anyway, Sayyid Lukman, welcome. And let me see who are there in the YouTube. Okay. YouTube, I don't find any person. Probably some people will come later. Okay, so directly I can come to the questions, whatever I do have. Just a few minutes back, I got a email from Aryan. He had asked me about the assignment 4, question number 1. So the particle growth by granulation and agglomeration is open. Yes, Aryan, you are right that if no binder input is given, then the first two options will not be active. But if you look at the figure that I have given, you will see the particle growth by granulation and particle growth by agglomeration. Both of them are active. They are not passive, They are not deactivated. So they are active. And specify outlet PSD that has been chosen. So if the user wants, he can choose either of the first two, but he has not chosen them. He has chosen the third one. So no binder input is given is not a false answer because binder input has been given, so the agglomeration option is open. Okay. Because hot air option is given, so those things are not false. What is false? The false is elutriation information is needed because typically elutriation information is not needed for granulator block unless you uh, want the elutriation to happen. I mean, if you think that elutriation is happening, then you can say, okay, this much has been elutriated. Otherwise, what is the granulator? Granulator, you just have the binder, you have the feed, and then granulate. So there is no ambiguity in the question. I think you have not understood the question properly, or you have not gone through the methods properly. That is the reason, Aryan, I always tell that do not take both the courses together. You have to be thorough with the basics, then only you take the advanced one. Anyway, so let us go to the questions that I have got in the Excel file. Okay, let me open the Excel file. There is someone called Virendra Singh Parmar. I don't know whether Virendra Singh Parmar is there in the YouTube. He is definitely not there in MS Teams. So, Virendra Singh, are you there? If you are there, please tell you are there. Okay. Anyway, he has asked me about the chlorine scrubber and all, what property package, property method he wants to use. So actually for chlorine scrubber, I would use an elect NRTL or ENRTL RK method. Yeah. If it's a high pressure system, okay, then I will use ENRTL RK. Otherwise, elect NRTL is enough. And then he also has a follow-up question about sometimes we face problems in property package during the run. The warning issue shows that structure does not define or some molecular, but molecular are not considered during the calculation, mostly for benzene ring with chloride as attached to it. Then how to address this warning, or else we can neglect the warning, go with available result. Does it make major changes in the output? Okay, Mr. Parmar, until unless I see the simulation, I cannot comment on that. One thing is sure that warnings are not good. Okay, sometimes we neglect the warning and go ahead and do the simulation, but then we do not have any confidence in the result if the warning is there. Okay. There is a warning means the system understands that something is going wrong in the calculation. For instance, some of the, suppose, for example, if you say that, okay, it's an ethanol water mixture, and you do not give any component of ethanol, okay, so you might or might not get a warning because system will say it is ethanol water mixture and there is no ethanol in it. So it's only simple water, right? So if you use an NRTL method for that, then it might look for the second component, ethanol component. But if it is not there, then the system might think that, okay, the user is asking for NRTL, it's telling it's a mixture of ethanol and water. Then where is ethanol over here? So then it will give some warning. So warning is there means it's an alert that uh, you have to honor it. Okay, you have to attend it. So I would suggest not to neglect the warning, but sometimes we neglect it and arrive at the final result to check where we are. And gradually we try to, get the things correct, and warning free and error free simulation is what we desire at the last. Then someone called Mr. Bala. He's saying need a brief from assignment 6 part B problem statement to clarify and get continued with the simulation. What clarification you need, Mr. Bala, I do not know. So you have to appear uh, in the screen or in this live session, and then you have to tell exactly what problem you face. Then only I can address this problem. And then I can go to the YouTube again. Okay, so someone named draconicball.tz said, okay, whoever he is. So he is asking if particle size increases during a granulation process, but no new material is generated, why is this considered passive growth and not active growth? Explain in terms of mechanism. I mean, what is the definition of active growth and passive growth in granulation? As far as I remember, uh, uh, if there is any uh, molecular activity in the form of reaction, then only the question of active growth comes. I'm not sure, but that's exactly what I feel. But I do not have ready answer to it. Uh, but definitely in simple granulation process, the actual motive is to increase the size of the particle. If they are powder, then we want to increase the size of the particle and make it granular. So it's a passive increase or passive growth only, right? So let me check. Okay, I was partially correct. Actually, in passive growth, um, it is about two similar size that collide and stick together. So that is passive growth. Okay, and active growth, the fine powders, they have a kind of grow because of the molecular activity, and then if the if the if there is a van der Waals force that is, due to that van der Waals force, that thing is being stuck together, molecules. So that actually is active growth. Okay. So probably in the example that I had shown in the granulation process, we talked about the size increase of the particle. So earlier the size of the particle is this, and later the particle size is increasing from this size to that size. So already it is in a granuled condition. So it's a passive process. So that I forgot the exact thing in the uh, video lecture that I have discussed, but I believe that's what I have told about active and passive thing. Okay. Okay. So I didn't find many people over here today. So whoever has come, you may please continue asking me questions, then I can answer.
Hello, sir.
Yes, Lukman.
Sir, in the week 6 assignment, part B question, there was a component titanium dioxide.
Weak, which weak?
If I see titanium dioxide, sir.
Which week?
Week 6.
Week 6, okay.
If I go to the component list of Aspen Plus, there are 2 titanium dioxide present there. One is called anatase and the second one is called rutile. Which one to use, sir?
One minute. Okay. Yes, Lukman, actually, I understand what you're saying. As I find that titanium dioxide rutile is there in pure component, pure 40 data bank, and titanium dioxide anatase is there in inorganic data bank, right? But if you look at their molecular weight, then both of them are 79.86 or 87. So basically, what rutile and anatase are, they are two different crystalline form, right? And here in the granulation, I do not know what problem it is. Let me check. The problem, it is about centrifuge, right? So it is a centrifuge.
Actually, I have used both of them in 2 different simulations, but due to the rutile, the anatase, I was using anatase one. I have got 2 answers. 2 of my answers are wrong because of that 0.01 increase in molecular weight. I tried the same with the rutile one, and my answers are turned out to be correct.
Which question?
1 minute, sir. It was the 8th and 9th, sir. 8th one and the 9th one.
You mean to say the cake thickness and solid density?
Yes, sir. For the cake, maximum cake, this have got 12.85 something. And the solid density filter block is I got 2662. Which is far away from both the ranges given provided by NPTEL.
In both the cases, I mean, anatase and rutile, both the cases you have got the same answer.
No, sir. This is because of the rutile, I think.
Sorry?
Because of anatase, sir. Rutile was correct. Anatase was in both the answer anatase I got higher values in anatase. Rutile's answer was correct.
You mean to say you have used different crystalline forms and your answers are so different?
Yes, sir. Let me show you my screen once again.
Oh.
1 second.
Yeah, please show it. No. I want to see your simulation. Can you share your screen? Are you using a...
I'm currently on mobile phone, sir. Let me change to my laptop real quick.
Okay.
Just
okay.
a minute. I will be back.
Yes. Because it should not be a problem, it's just a crystalline structure. So I do not know why the crystalline structure will be a problem in this centrifuge. Centrifuge and then the filtration. In either case, the difference in crystalline structure should not be a problem, right? And moreover, if you type TiO2 in the component, then by default, I think it will bring in rutile form, not anatase form. Because it always tries to get it from pure component first. If it is not there from pure, then it will take from the inorganic. Yeah. But I'm surprised, with only a change in crystalline form, how come so much of difference is coming?
Is my screen visible? Sir, this one is the rutile one.
No, you have to
And this one
show
is
me you have to show me the entire simulation, please.
Just a second, sir.
Show me the entire simulation.
Sir, I have used annotates here and I actually forgot to save the rutile one. So currently I only have this one.
Okay.
If we go to the simulation environment and filter results, here there is 1.28 something micron, 12.8539 micron and the average solid density is 2662.63.
Okay.
The answer is actually this one.
No, it gives me a kind of surprise because I never thought that that will be. I hope you have put your data points right. But you go to the properties. You go to the properties. Then go to the third row, the blank. Put your hand. There you write TiO2. Just write TiO2 and press enter.
I'm getting the rutile one.
So by default, it will come rutile 1.
Yes, sir.
Okay. By default, it will come rutile 1. You do not have to go and find it from there. And the reason is you go to the enterprise database, top, the fifth tab, enterprise database.
Sir, where exactly?
Selection, petroleum, non-conventional. Right, wherever your mouse is. You see, the selected data banks, first it is pure 40.
Yes.
Okay. And
yes.
Inorganic comes at the end.
Fourth one.
I mean, not fourth one.
Ah.
So now, if you put like that, okay, just 1 minute.
Inorganic on top.
Yeah, actually, that's the problem. I mean, if you use it in a still it is coming, huh? Okay, okay. So actually, in the LIS, they have put it. Yeah, they should come. Actually, this titanium dioxide, I mean, it is not in the name of TiO2 in that. It's in the name of TiO2A. Okay. So when you are writing TiO2, then it is getting a sure shot thing from the pure 40. So it is picking up from there, I believe. So that's what is happening. Okay, I have taken a note of it. So what is your so what answer did you get? I mean, did you get correctly in the assignment?
No, sir. I actually got 2 of them wrong.
Okay, okay, okay. So centrifuge question is correct for you. Only the filter thing is problematic, right?
Yes, sir.
Yeah. Now I understand the filtration. You know the crystalline structure will be a problem for filtration. It should not be any problem for the centrifuge because centrifuge, the operation is different. But filtration, the shape matters, isn't it? The shape of the particle matters. Because it is a crystalline structure, no, the crystalline structure, TiO2 solid, anatase and rutile, they have two different crystalline structure. So the shape matters in filtration. So, I mean, rutile, I think it is a tetragonal structure, more compact. But anatase will be more open. I mean, it's also tetragonal, but it is more open structure.
Okay.
So it's not that compact. So it matters.
Okay, thank you, sir. Thank you.
Okay, okay. Okay, any more question? Okay, Sayed Man. Let me check the YouTube. Okay. In YouTube, Draconic Ball is asking, but in certain processes, binders or solvents create solid bridges that might later crystalline or crystalline. How do we decide between passive and active particle enlargement? Binders or solvents create solid bridges that might later crystallize or precipitate. Uh, I do not know what exactly you are trying to say. What do you mean by solid bridges or precipitation over here? Because the activity is simple, right? I mean, what is the granulation process? Granulation process is um, powdery material that is having uh, very small size. They grow up, they granulate. So, so one particle, then binder will, have another particle on that, and it will bind with others, and size grows. Okay, so that is a granulation process. That is active process, right? That is active process. And passive means two granules of the same size, they coalesce. They coalesce with each other. Obviously, the binder will be playing a role. And that might be something like solid bridge that you are talking about. So that is passive. So active and passive, their definitions are very straightforward. So what is there to decide between passive and active? And as far as your simulation is concerned, do you have to choose something depending upon whether the system is passive or active? I do not think so. I mean, solid bridge is rigid connection formed between two particles when a liquid binder, dissolved substance, or molten material solidifies or crystallizes at the contact point. Then it will be some sort of coalescence, right? It should be passive, not active. I mean, that's what I understand from the definition of it. Probably, I mean, you have to get this thing clear. In fact, I also have to get myself clear on this, whatever you are saying. But from the definition of active and passive, I can say that whatever you are saying, that is more of an passive granulation than active one. Okay. Okay, any more questions? Yes, Vanian, sir, can I ask out of this discussion part question? Can I ask, Vanian? Adian? Okay. No, Vanian, this is not the right question for this forum. You can ask me offline, okay, some other time. Okay, so I believe there is no more questions in this forum, and not many people have attended also. So let us close it. Okay.